So today we will start with a new topic that is IPv4 addresses. So in our previous sessions when I was discussing spanning tree protocol and when I was giving some IP addresses to the PCs, you would have seen me giving an IP address like 10.0.0.1, right? So this is one of the examples of how an IP address basically looks like. Okay. Now, what is an IP address? First of all, let's try to understand. There is so this IP. Okay. First of all, the full form of IP is Internet Protocol. Okay. So the name suggests Internet Protocol addresses. Okay. Now, what is Internet Protocol address? An IP address is an address just like our home address, which every networking device will have. It's like an address for networking devices. Okay, address for networking device. This is what basically an IP address do. So your laptop, your PC, your mobile phone, even your smart TV, nowadays even our smart fridges, they have some kind of IP address. Okay. So just like our home address is we have a home address which anyone who has this address can identify our location, he can reach our location, and he can be in front of us, right? Similarly, an IP address for a networking device plays the same role. So you send any data out in the network, it will have an IP address, and seeking that IP address, the data will reach that particular destination. Okay, we can easily understand it. But as a laptop or as a printer or as a server, google.com is not readable by any networking device. It needs to be converted into its respective IP address. Okay, we'll talk about that later. How is it converted into the respective IP address later? But anything on the internet to reach or to send the data towards that particular destination, you need an IP address, or that particular networking device needs an IP address so that the data can reach it. Right? That is the purpose of an IP address. Now, as you can see already here, the IP address is written in this format. Okay, that is A comma B comma C comma D. This is what an IP address is basically written like. Okay, so it's not like ABCD is ABCD should be different numbers. They can be same numbers. They can be different numbers as well. But they're written in A dot B dot C dot D format like this. 10.1.2.3 like this. They can be written in this format as well. 10.1.2.3. This is how you write an IP address. Now, each number over here, each number, okay, we can see it is divided or it is separated by 3 dots, right? And each dot basically separates 1 octet. It separates 1 octet. Octet meaning that this particular number, whatever you write over here, is an 8-bit number. It is an 8-bit number. So even if you write 10.1.2.3, you need, or a computer or any networking device will convert this 10 into an 8-bit number. And we know that 1 bit is either a 0 or a 1, right? So you have 8 such bits which the computer will convert this number into its equivalent binary form. And then only it will understand this number 10.1.2.3. And because it is an 8-bit, it's called as an octet, right? So you have 4 octets. You have 4 octets which will be written in this format 10.1.2.3. That means each number that you see here is an 8-bit number, is an 8-bit number. So if all of them are 8-bit number, this means that the total size of this IP address is 32 bits, right? 8 bits, 4 octets, giving us 32 bits of an IP address. Right? So an IP address is a 32 bits number with which a networking device is identified in the network. All right, a very simple definition of what an IP address is. Now, just like we have classes in in schools, we have first class, second class, third class, fourth class. Similarly, an IP address also has different classes. So first, classes of IP addresses. Now, please remember, whatever IP address we are learning is IP version 4. We are learning IP version 4. We will learn IP version 6 later, but to understand the concept, it is always easier to understand with IP version 4. Okay. There are versions, IP version 1, IP version 2, IP version 3, etc. There is IP version 4, which we are learning now. There is IP version 5 also, and there is IP version 6. Okay. These two are majorly, not majorly, are the existing IP versions that is used in the network. These versions probably, to be very honest, nobody knows what happened to them. Okay, obviously they must be a trial and error versions, and finally an IP version 4 came into existence, which even today it exists. And then there was an experimental IP version 5, which was no longer successful, and then we landed into IP version 6. Okay, now classes of IP address. So you have 5 classes of IP address, namely class A, class B, class C, class D, and class E. These are the 5 classes of IP addresses. Now, what do these 5 classes of IP address mean? So this class is defined or identified. This class is identified based on the first octet. Based on the first octet. Okay, so we know that an IP address contains 4 octets: 1, 2, 3, and 4. So 1 octet, second octet, third octet, 4 octet. So this class is basically identified. The class of an IP address is identified based on the first octet. All right, and how is it identified? Let's check that. Now, if the number on the first octet, let's say the first number or the number in the first octet, if it is between 1 to 126, starting from 1 till 126, that is a class A IP address, meaning that if I write the IP address as 10.1.2.3, you can see this 10 is between 1 and 126, and hence it belongs to class A IP address. Okay, what is the class B IP address? If it belongs from 128 to 191, let's say I write the IP address as 150.10.11.100, something like this. Okay, so the first octet number bit is between 128 and 191, and hence it belongs to class B IP address. Class C starts from 192 up till 223. Okay, so let me write the IP address as 192.168.1.1, something like this. Right. So this number is between 192 and 223, and hence this particular IP address belongs to class C. Class D IP address starts from 224 up till 239. 9. So if you write an IP address, for example, 230.1.1.1, for example, like this is a class D IP address, and class E IP address starts between 240 and 255. Okay, so any IP address, let's say 245.3.2.1, this is a class E IP address. And as I said, this is how you basically identify the class of an IP address by the first octet. Whatever number is present in the first octet, based on that, you identify what class does it belong to. Okay, what class does it belong to? And obviously, you need to memorize. There is no mnemonic for it. There is no mnemonic to memorize class A, class B, class C, class D. If there is, please do let me know. But I had to memorize this particular mnemonic, not mnemonic. I had to memorize these numbers anyway. Okay. So the classes of an IP address is identified based on the number that is present in the first octet. Right. Now, again, what is the significance of these numbers? Why have they been divided into different classes? And before we jump into that particular part, as network engineers, we will be mostly working with the first three classes: class A, class B, class C. As network engineers, we will be dealing with class A, class B, class C in most of our course, as well as in real time also you will deal with these classes on. Class D is called as a multicast IP address. When we will be discussing few routing protocols, we will discuss multicast. And class E is an experimental class. It's very, very rarely used in real time. And probably we will not even see these experimental IP addresses being used in any of the courses as well. Okay. So class A, class B, class C is majorly and extensively used in the courses as well as in the real time as well. Class D is the multicast class and class E is the experimental class. Now, coming to a discussion as to why are these classes important and why does it matter for a networking device or for us also as human, why does understanding the class of an IP address is important? Okay. Now, to understand the concept of whatever I'm going to tell you, why the class is important, let's try to understand how these IP addresses are basically divided or distributed in the world. Okay. So there is an organization called as IANA. To be very honest, I forgot the the full form of IANA. I think it is International Authority Number Authority, something like that. Okay, you can just Google it. Okay. IANA is an organization which basically distributes these IP addresses to the devices or the networks in the world. Okay, it is responsible to distribute the IP address. So what I'm going to tell you is a very hypothetical, it's a very hypothetical situation that I'm going to give you, but it's a very a simple way of understanding how IP addresses are distributed. Okay, so imagine, obviously we have different continents. So you have Asia over here. Okay, then bottom you have Australia. Over here you have Europe, Africa, right? And here you have Antarctica. Obviously, Antarctica we are not going to take into consideration as of now. Then you have North America, and then you have South America. Okay. So these are the 7 continents in the world, right? Now, what IANA said that what IANA said that every country, for example, every country in Asia will have an IP address starting with 192, for example. All the countries in Asia will have the IP address starting with 192. So now, if anyone wants to find out the country, or if anyone wants to go to Asia, they will say that the IP address should start with 192. Correct? It can be any country in Asia. There are so many countries in Asia. Okay, India is one of them. Right. So 192 will be the IP address, or it will be the starting number of the IP address of every country in Asia. So let's bring it down. India is one of them, right? So India will also have an IP address which starts with 192. That means all the places in India, all the places in India will have an IP address that is starting with 192. I hope that is clear. Okay. Now, different ISPs in India, they decided that for each and every state, the numbers should be different. For each and every state, the numbers should be different. And please remember, what I'm telling you is a very hypothetical scenario, but it is a good scenario to understand how IP addresses are distributed. So in India, there are different states. Let's say for Maharashtra, okay, they said people living in Maharashtra, their IP address is obviously starting with 192 because it's in India, right? And for people in Maharashtra, the IP address, for example, will start with 168. So every district, every person who is using a networking device and he is living in Maharashtra will have an IP address starting with 192.168. Correct? He can be anywhere, he can be living anywhere in Maharashtra, but his IP address will start with 192.168. Okay. Then the Maharashtra ISPs, they said for for different districts, to identify different districts. So you can say for identifying different districts, we'll give different numbers. And they said, okay, for people living in Mumbai, their IP address or the number will be, let's say, 10. Okay, so 192.168.10. So everyone who is living in Mumbai will have an IP address starting with 192.168.10. Okay, then assume that there are only 255 people in Mumbai. Again, as I said, it's a hypothetical situation. Imagine there are only 255 people living in Mumbai. So the first person who is in Mumbai will have an IP address 192.168.10.1. That's the IP address of the one person in Mumbai. The second person will have an IP address .2, third will have .3, fourth will have .4. Similarly, the last guy will have an IP address .255. And please remember, all of these guys are from Mumbai. If they are from Mumbai, their third octet number should be 10. Right? Because they're from Mumbai, that means it's from Maharashtra. So their second octet number should be 168. Because it's Maharashtra, they are in India. So in India, and because in India is in Asia, every number will start with 192. Okay. So this is how basically an IP address is distributed. Again, I'm giving you a very hypothetical scenario. All right. Now, if you from instead of IP address, let's start to think this from our house address format. Okay. So let's say that flat number 15, for example, flat number 15, A, B, C, D. flat number, let's say A202. Okay, flat number A202. Okay, ABC Society, ABC Society, DEF area. Okay, DEF area, and let's say Chembur. Chembur is, I am not sure if you guys know Chembur. Chembur is an area in Bombay. Okay, Chembur, Mumbai. Okay, this is an address in Mumbai of a resident in Mumbai, for example. Okay, this is a made up IP, sorry, address. Now, every resident living in this society, except for the flat number, rest of the address remains the same. Correct? The neighbor of A202, for example, that neighbor is A201, right? He will also have the same address except for the flat number. Similarly, a person living in a different building, okay, let's say C building, okay, and he's living in the 10th floor, and his apartment number is 10001. So you see here, the only thing is his apartment number or flat number changes, whereas the rest of the address remains the same. Correct? Similarly, over here, now think this from the IP addresses perspective. The flat numbers are changing. The flat numbers are changing. However, the rest of the address remains the same. The rest of the address remains the same. Okay, now let's take this a bit further. Let's take this a bit further. In DEF area, there will be many societies. Okay, for example, there will be ABC society. There is an XYZ society. There is an element society, for example. There are different societies. But since all of them are from the DEF area, the only thing that will change for them is the flat numbers and the society name. The rest of the IP or the rest of the address remains the same. Similarly, over here, if you see over here, this is same. Okay, for people living in Bombay, the IP address will be same. For people living in, let's say, Nagpur, the IP address may be like 192.168.11 is the number for Nagpur. And then people living in Nagpur will have 1, 2, 3, 4, 5 till 256. So for Nagpur, 11 is the number. For Kolhapur, 12 is the number. For some other city, some other number is present. So a subset of the whole IP address remains the same, whereas the other thing are constant. Is this concept clear?
Yes.
All right, Pankaj, for you, is it clear?
Yes.
Yeah. Now, in IP addressing scheme, in IP addressing convention, the things that are changing, you can see 1, 2, 3, 4, 5, 6, they are changing. They have allotted to different users and they keep on changing. The this change or the changing part in an IP address is called as the host part. Is called as the host part. The part which remains the same for all the users or for all the hosts. The part in the IP address which is constant. The constant part of an IP address is called as the network part. is called as the network part and the host part. The host part is like this in the IP address over here. The first example that I showed you, this particular octet will be called as the host part because that's the only number which will change. But the rest of the octets, the rest of octets 192.168.10 is same, right? So that particular part will be called as the network part of an IP address. Network part and host part of an IP address. Host part is the part which keeps changing. The network part is the part which is constant in the IP address. Is this clear? Any question of what is network part and what is host part?
No, yes, clear.
Clear.
So why did I take this network part and host part into consideration? The reason is your classes, class A, class B, class C, class D, and class E. We are not going to consider classes D and E as of now, but class A, class B, and class C also have their own network part and also have their own host part, meaning network part for class A, network part for class B, and network part for class C. All right. So let's say 10.1.2.3. This is the IP address of a class A because 10 belongs to a number between 1 to 126 and hence it is a class A IP address. So in class A, first octet or one octet, let me write it as one octet. One octet is network part. 3 octets are host part. Meaning that in class A IP address, only this octet is going to be the network part and this 3 octets are going to be host part, meaning that 10 will remain constant for every IP address or any other number instead of 10 between 1 to 126 will remain the same. The rest of the IP address will change. 1.2.3. Okay. This can be 2.1.3. This can be 100.200.10. Okay. Then 4.5.6 or any other number you can think. Any number between 1 to 255. Any number between 1 to 255 can come in these 3 octets. But the first octet will always be the same. The rest of the octets will change. So it's not just 10. It can be 2 also. 2.3.4.5. So 2 is the first octet, so it will remain the same. 2.200.100.50. Okay. 2.70.90.1. 2.10.0.1. So you see here, the first octet remains the same. The rest of the octets are changing. So this is the host part and this is the network part. Okay, and in class A, the first octet is always the network part. The last 3 octets are the host part in class A. Again, in class A, the first octet is the network part. The last 3 octets are the host part. All right, for class A. Similarly, for class B, 2 octets are network part and 2 octets are host part. So if I write an IP address, let's say 172.1.2.3. 172 is between 128 and 191, and hence it's a class B IP address, which is what we are seeing over here. Class B is between 128 and 191. Right. So this is 172.1.2.3. So in a class B IP address, 2 octets are network part and 2 octets are host part, meaning that the first 2 octets are network part. They will not change. So 172.1, okay, first is 2.3, it can be 2.4, then 172.1, it can be 2.5, 172.1, it can be 5.2, 172.1.100.200, it can be like this. 172.1.200.100 can be like this as well. So in all these IP addresses, you can clearly see the first octet remains, the first 2 octets remain the same. The last 2 octets are changing. So in a class B IP address, first 2 octets are the network part and the last 2 octets are the host part. Okay. Now, as I said, it's not necessary. It has to be 172.1. It should be a class B IP address. It can be 128.0 also. But the first, it will always be 128.0. The rest of the 2 octets will keep on changing. Okay. Now, what is the significance of network part and host part? We'll try to understand later. Okay. But I'm just trying to give you brief, and I'm trying to put in as slowly as possible to make people understand the concept of IP address. Next is class C. Class C. In a class C IP address, 3 octets. Yeah, 3 octets are network part, and only 1 octet is a host part. That is the last part octet. So if I write an IP address 192.168.1.3, for example, okay, this is a class C IP address because it falls between 192 to 223. Okay, that is why it's a class C IP address. And in over here, as I've written, 3 octets are network part. That means the first 3 octets are the network part, meaning that only the last octet will change. The first 3 octets will remain the same: 192.168.1.1, 192.168.1.2, dot 3, dot 4, dot 5, like this. So the first 3 octets in a class C IP address is the network part, and the last octet for class C IP address is the host part. All right. Any question, understanding what is a network and what is a host part, and what are the different network and host parts in different classes? Any question over there, or anything you would like to add?
No, I think it's good.
All right. Okay. Now we understood what is a network part in an IP address, what is a host part in IP address, and we also understood how many network octets and host octets are present in each classes, class A, class B, and class C. Okay, but what is the significance of this network part and host part? That is still unclear, or I have not mentioned it till now. Let's try to understand what is the significance of network part and host. Okay. Let's start to understand from class C's perspective. Class C. And let's take the same example of 192.168 1.1.1. Okay, and we know that this is class 3. We just saw first 3 octets are the network part, and the last octet is a host part. Okay. Now, we just saw how IP addresses are assigned to different organizations or different parts of a country. As I told you, it's a very hypothetical situation that I showed you, but it's a very good way of understanding how IP addresses are distributed. Now, let's think from a class C's perspective. The first 3 octets, 192.168.1, will remain the same. That is the network part. The only part that will be changing is the host part. That is the last octet. Now, in an IP address, this is true for all the classes. This is true for all the classes. The host part of the IP is assigned to hosts, as the name suggests, is assigned to host. When I say hosts, it's basically a LAN network. Okay, it can be an end user like a PC. Okay, it can be a LAN, it can be PC, it can be your laptop. Okay, it can be a server, anything. The host part is basically assigned to hosts. Now you may be confused. LAN is not a host. Yes. Okay, we'll come to that perspective later. LAN is not a host, but as I said, the host part is assigned to host or end users. Okay, so let's assume that there are 255 PCs. There are 255 PCs, and all of them have a class C IP address. So 192.168.1. The first PC will have an IP address 1. The second PC will have an IP address 2. Third PC will have an IP address 3.4.5, like this till dot 255. So you can clearly see the first or the host part of the class C IP address is assigned to end hosts. Similarly, for every other classes as well, the host part, it can be 1 octet host, it can be 2 octet host, or it can be 3 octet hosts. It is still assigned to different parts of the network, and it is assigned to hosts. Okay. Now, so we just discussed what are the different classes. Okay. And we have 5 classes: class A, class B, class C, class D, and class E. Right. And we had just discussed class A belongs the first octet value. You can see IP addresses based on the first octet values. Okay. So 1 to 126 is class A, 128 to 191 is class B, 192 to 223 is class C, 224 to 239 class D, 240 to 255 is class E. Okay. And if you see the below table, you can see different octet parts and different host parts that is mentioned. Okay. So in class A, you will have 1 octet. In class B, you will have 2 octets. In class C, you will have 3 octets of network part. In class A, you have one network octet, 3 host octet. In class B, you have equal amount of network and equal amount of host octets. In class C, you have 3 network part and 1 host part. Okay. And Any question till here?
No, till here it's fine.
Okay, I think I'll stop our session today for now because even I need to collect my thoughts of how to present IP addressing in the next sessions. Okay, so tomorrow we'll continue with IPv4 addressing and especially uh, again talking about the same thing. What is the significance of the network part and the host part?
Okay.
Right?
Sure.
I just started. I didn't move into in depth about it, but tomorrow we'll go inside that as well.
How many sessions you will host on this IP, Laksh?